So for this implicit differentiation, we have the question, find the slope of a curve for 2 points. And the reason that it can ask that we find the slope of a curve for 2 points is that in implicit differentiation, we will often find that we have more than one solution. So we first will simply take this equation and we will find the equation for the slope of a curve at any given point. And then we will use the points given, and from that, we will find out what those individual slopes are for that tangent line. So let's go through this. And to begin with, we just need to take a look at what we're working with here. And it doesn't look like we have any products. This is not a quotient. So this should be fairly simple. We're going to start off by saying that we want the derivative with respect to x for x squared minus the derivative with respect to x of x. And of course, you don't have to break it up like this. I just want to show you what we're doing individually. So we have that plus the derivative, d with respect to x, for 1. And what we do to one side of the equation, we must do to the other. So then we will have the derivative with respect to x of 0. So from here, we are treating this y squared in a way that is similar to the general power rule. So we're going to bring that exponent down. If you remember that y is essentially a function of x. So if we had x third minus 2 raised to the second, we know that we would need to bring this down using that general power rule. We would have 2, just bringing that down. So we would end up with 2 coming down to the front. And that is essentially what we're doing here, is we're going to bring that 2 down. We're going to have y. 2 minus 1 is just 1. So we have 2y. But because it is a function of x, we must also use the chain rule. So it's the general power rule and chain rule, which means that we could immediately write the derivative y with respect to x, which is what we're going to be doing. But to show how this works is we would then multiply this using the chain rule, multiply this by the derivative with respect to x of just y, not the exponent, a function of x. We would just be taking then the derivative y. Well, anytime that you see just the derivative d with respect to x of y, we are going to write that from now on as just the derivative y d with respect to x. And that's what we're trying to end up with. So let's continue. And the rest of this is just going to be what we have been doing with derivatives. So it's going to be minus, and we're going to have x is just simply going to be 1, and we will have just 1 plus the derivative with respect to x of 1 is just going to be 0. And then we have the derivative on the other side of the equation that is also 0. So we will end up with 2y dy dx minus 1 is equal to 0. From here, we want to isolate dy dx. So in doing that, we can add 1 to both sides, and we will end up with 2 times y times dy dx is equal to 1. And then we can simply divide. To isolate dy dx, we can simply divide both sides by 2y. And we have solved, at least for the equation, the equation for the slope of a curve at any point, and we will have dy dx is equal to 1 over 2y. We're not finished though. We were asked to find the equation for the slope of a curve, but we were asked to find it for two different points. So we're going to find what the slope is at 2, -1 and 2, +1. So using those points, we are simply going to insert x and y if there is an available variable that corresponds to x and y. In this case, we see that there's only y. So we're going to start with our first point. Our first point is 2, -1. And we are going to substitute for y. So we're going to have dy dx is equal to 1 over 2 times -1. And that is simply going to give us the slope of -1/2. Our second point is going to be 2, 1. And when we substitute that, we end up with, we have dy over dx is equal to 1 over 2 times 1. And we end up with a +1/2. So we have two different slopes. And we can continue. We can then find the equation for the slope of a curve at those points. And if we did that, then we would have the point 2, -1 with a slope that is equal to -1/2. And we have point 2, 1 with a slope of +1/2. And we would then just plug those in. So we have y minus -1 is equal to -1/2 multiplied by x minus 2. And we have y minus 1 is equal to +1/2 multiplied by x minus 2. And we would simply say this is now a +1. And so we can say y plus 1, carry this -1/2 through. So we have -1/2 x plus, and we're multiplying, of course. So we're going to end up with 1/2 times 2 over 1. So we have just 1. And then we're going to subtract 1 from both sides. So we'll subtract 1. And for the first point, we find that the equation for the slope of the curve at point 2, -1 is going to be equal to -1/2 x. And for the second point, again, it's just basic algebra. We're going to carry the 1/2 through to each term. So we have y minus 1 is equal to 1/2 x. And here we end up again, in this case, we end up with negative. So we'll end up with a negative. And that's going to be -2 times 1/2. So you have -1. We're going to add 1 to both sides. And we will end up with y is equal to 1/2 x. And those are the equations for the slope of the curve at those given points. Thanks for watching. Hope that helped.